Let's take this previous JEE Advanced question. It is saying let f 0, 1 maps to R be the function defined as fx equal to root n if x belongs to 1 by n plus 1 to 1 by n, where n is a natural number. And g 0, 1 maps to R be a function such that gx lies between 2 root x and this function, which is given in integral form, for all x between 0 to 1. Then we need to find out limit x tends to 0 fx into gx. Limit x tends to 0 fx into gx. Now, as per the first definition, you see here closed interval is given 1 by n plus 1. So we can say that f of 1 by n plus 1 is also equal to root n as per the definition. Okay. Now here if I replace replacing n by n minus 1. If I replace n by n minus 1, we will get f of 1 by n is equal to root n minus 1. Right? So we know f of 1 by n. So here for calculating of this limit, let us put x equal to 1 by n, where n is tending to infinity. Okay? As n tends to infinity, x is tending to 0. So this limit will change to limit n tends to infinity f of 1 by n into g of 1 by n. Now, f of 1 by n value we already know. G of 1 by n, what is the bound of the function? We know the bound of gx, right? So here replacing x by 1 by n, replacing x by 1 by n. So what is the bound of g of 1 by n? G of 1 by n is less than 2 into 1 by root n, and it is more than integral 1 by n square to 1 by n root 1 minus t by t dt. This is the bound of g1 by n. So if I multiply f1 by n, f1 by n into g1 by n, for this function the upper bound will be f1 by n is root n minus 1, so that is multiplied to root n minus 1 upon root n, and here root n minus 1 is multiplied, so it will be integral 1 by n square to 1 by n integral 1 by n square to 1 by n root 1 minus t by t dt into root n minus 1. So f1 by n into g1 by n is lying between these two functions. Now, as n tends to infinity, can we think of applying Sandwich theorem? That is, let us find out the limit of the upper bound and the limit of the lower bound as n tends to infinity. So if you check the upper bound, for the upper bound limit n tends to infinity 2 times root n minus 1 upon root n. As n tends to infinity, root n minus 1 and root n, they are comparable. They are almost same. So they will cancel out to give the ratio tending to 2. The limiting value is 2. And what about the lower bound? For the lower bound, we can write the lower bound as, this one we can write as a limit n tends to infinity integral 1 by n square to 1 by n root 1 minus t by t dt divided by, let us take in the denominator, 1 by root n minus 1. Now as n tends to infinity, you see that the limit will be 0 to 0 integral, that is tending to 0 by tending to 0. So this is 0 by 0 form. This is 0 by 0 form. So applying L'Hospital. So if I apply L'Hospital, you will get limit n tends to infinity, derivative of the numerator by Leibniz rule, it will be root 1 minus 1 by n upon 1 by n into minus 1 by n square minus the lower limit, that is root 1 minus 1 by n square divided by 1 by n square into minus 2 by n cube. That is the derivative of the numerator by Leibniz rule, and whole divided by derivative of the denominator, that will be minus half into n minus 1 to the power minus 3 by 2. So what is this value? If I take this in the numerator, then it is going to be equal to, 2 into n minus 1 to the power 3 by 2 into, the first one will be into minus 1 by n square into n minus 1 to the power half. That is the first one if you simplify. And the second one will be 2 into plus 2 into n minus 1 to the power 3 by 2 into this will be root n square, another 2 will be there, into 2 into root n square minus 1, that is n minus 1 to the power half into n plus 1 to the power half, and whole divided by n cube, right? So what is the limit value of this as n tends to infinity? Limit n tends to infinity. Now here check here for the numerator, what is the highest power of n, because n is tending to infinity. What is the highest power of n? N power 3 by 2, n power 1 by 2, n power 1 by 2. So highest power of n is n power 3 by 2 plus 1 by 2 plus 1 by 2. That is n power 5 by 2. But the denominator is n cube. So compared to n power 5 by 2, n cube will be much bigger. So this limit, this part is definitely going to 0 because the numerator n highest power is less than the denominator n highest power. So that part is gone. So we should concentrate on this part. For this part, if you analyze, what is the limiting value? This part, if we concentrate, it is going to be equal to I think here plus sign will be there, and here second one here minus sign will be there. Because one negative was in the denominator also, this negative into negative, this will be positive. So limit n tends to infinity, this is n minus 1 power 3 by 2 into n minus 1 to the power half. They will multiply to give you n minus 1 square into 2 divided by n square. Okay. So when n is tending to infinity, these two are comparable, so they will get cancelled out, and we got the limit value to be equal to 2. So upper limit is tending to 2, lower limit is tending to 2. So by Sandwich theorem, we can say that this function as n tends to infinity is also tending to 2. So the limiting answer is 2.